Everyone, we're moving on to the next keynote from Johannes from Galadriel.
Hi everyone, my name is Johannes and I'm the CEO and co-founder of Galadriel. I'm going to speak about Ethereum for AI. And first, my own background a bit. I kind of tell myself that I'm an AI dinosaur because I've been in the space since 2018. So before none of the LLMs existed, and we were actually developing neural nets with LSTMs. And founded 2 AI startups and also one Web3 one NFT board where we raised a 26 mil A round. I'd like to start with a story. It's 2017. I got a call from my ex-team members in NATO, and they said the situation is bad. The reason being is because that was the day when WannaCry, one of the most notorious ransomwares, hit a lot of critical infrastructure in the world. And in 24 hours, it already had also taken down hospitals in London. So the reason why I used to work in cybersecurity was because at the end of the day, it's never about protecting technological systems, but human lives, protecting human lives. And although I'm extremely excited about the recent progress in AI, because I'm also a technologist, I'm also worried. And the reason I'm worried is because we have a small problem. The problem is that once we create something much more smarter than us, we don't know how to control that. And in evolution, in history, it has never happened. And so if you, for example, read this recent paper called Situation Awareness, it also explains this quite well. I recommend you Google it, it's Situation Awareness and AI. And so what are some of the problems that AI safety today is having is, most of you probably have heard about RLHF, reinforcement learning for human feedback. The problem is, using a few $100, you can take all of the open source models or even closed source models such as OpenAI, and you can fine-tune the safety layers off. So as a safety mechanism, it really doesn't work. Well, again, coming back to the cybersecurity, one of the biggest things that I learned is security through obscurity never works. And like, it's a guaranteed fact that the major AI labs today are already infiltrated. So once those really powerful models are developed, the trade secrets are created, in just a matter of time, it will be in the hands of other nations. And so here is a recent Wall Street Journal article where actually, like Google, imagine the amount of resources Google has to cybersecurity systems. And again, you know, their DPU architecture were stolen. And it's a question of, you know, when shit hits the fan, like, whom do we call? This guy, right? That's the kind of status quo that we have at the moment, hoping that, you know, he gets everything right. And we have like one shot on the goal. So AI safety as it is of today is largely marketing. Now, if you ask, okay, it's a problem, then how much time do we have? And we look at the main people driving that progress, everybody from Sam Altman, NVIDIA, CEOs, Elon Musk, whatnot. The most of them basically bring it out, it's in the next 6 years. So that's how much fix he is. That's how much weeks we have left until 2030. I just ticked off the ones in red that we already crossed. So as you see, it's not much. So we believe that in the next 5 years, the biggest challenge the world will face is not climate change, it's not wars, but it's the fundamental question of if we as a human species will take control of this planet. And that's the reason why we're building Galadriel with the mission of being ETH for AI. And at its core for us is how do we actually make sure or be part of making sure that humans take control over AI. Second part of that is AI ownership. I've definitely been spoken about this a lot already today. And thirdly, it's about having the ethos of ETH itself, making sure that from a developer's perspective, how I build AI applications, they are truly decentralized, and also the developer experience is easy as eat today. So simply what we do is, as a developer, you can write Solidity and deploy on Galadriel, and you can have decentralized AI applications. Now, why should devs care? And I wrote this question from the perspective of not only from Galadriel, but if I'm actually building anything in decentralized AI, then, well, first of all, kind of the first product market fit ETH had wasn't ERC20, but it was a platform where developers couldn't be shut down. Because previously, such as Facebook's, Meta, etc., Twitter shut a lot of developers down when they got successful on top of them. So it's like a platform for developers where they can be free. Secondly, pre-creative new use cases, and thirdly, actually earn monies. I think the whole kind of decentralized AI space today is in this phase. Like, almost no developer is earning money, and the platform is still like day one. But that's at the end of the day where we should, as an industry, progress to actually make a dent. So what are the use cases developers are building with and being creative with, what we are seeing? And our DevNet has been live for the last 3 months, and over 50 teams have built on us. So first category, gaming. Here's a few examples. I'd like to highlight the middle one, the Civ AI. Probably many of you, at least you're a gamer, you know this game called Civilization. So this is kind of like Civilization, but with AI agents and on-chain. So you have to gather resources, you have to combat against other AI agents. Then a lot of creative use cases. One on the right side, for example, being, you can imagine user adding an input to an NFT, and that NFT is generated dynamically based on the user input. So it's basically always new. And so it's kind of like on-chain Midjourney or on-chain Dolly. What about finance? So on the left side, quite an interesting use case by one team where there is a problem of gathering data, especially action data, which today models aren't able to do. And they incentivize, let's say like if you go to Twitter, you want to do like action X, click on some buttons, and using on-chain vision model, if the data submitted by the user is good enough, then you get tokens. So it's like incentive mechanism to generate good data. Or there's a middle one where a user can submit his claims and on-chain AI agent qualifies if that claim is valid or not and pays out. Agents, there's been a lot of talk about AI agents, but actually we're seeing quite a lot of agents being built on top of us. On the right side, for example, the Task Llama is even kind of like AI agent Craigslist. So users can submit tasks there, and there's an agents who complete these tasks, submit the results to on-chain, and there's evaluator agents who check if the payment should be done or not. Also on the left side, the actor model agents is like agent swarm, basically. So you have one agent that is able to deploy many multiple agents as smart contracts themselves and handle out the tasks, and all of the payment is on-chain. All right, so how does Galadriel work? Before I dive deep into that, what about how do one actually put AI on-chain? So what are the main challenges one faces? The first one is how do you actually verify the inference itself? Latency. Putting anything on a blockchain has a massive overhead in terms of latency. Indeterminacy. So models themselves aren't deterministic by nature, so the output isn't deterministic by nature. Data privacy. Again, if you use blockchain, data is public on-chain. Cost overhead. So let's say like if one OpenAI API call costs X, you don't want to pay, developers don't want to pay like 100 times more than that. And also especially in the cases if one uses agents, then the sync nature, meaning agents run in a loop. It might take like 30 seconds or 1 minute to run, but how do you fit that in one block? So it's basically a challenge. I'm not going to go deep into all of those. I take another presentation, but those are some of the constraints, the challenges that we have faced among others while designing Galadriel. Now, coming back to the point of ETH for AI. So at the end of the day, it has to be as simple to use as ETH. So this is the kind of developer experience that we provide. So hopefully enough people understand Solidity here that you basically import this precompiled address. And the precompiled address on our chain is native. So it's on the node level itself. So it's precompiled contract. You're able to import that and then basically start through inferences against different models. And those models, let's say in this case it's Llama 3, there's no providers who run those models. Those take money, they earn money based on the inferences made. And there's also a callback. When the inference is completed, then that callback is made. Now here is a very complicated chart. This is our architecture diagram. I know it's hard to read, and it's fine. You don't have to read all of the micro text, but I'll just explain very high level. So this side is basically, this was the Solidity code that I just showed you. This is a client, RPC, that connects to our nodes, validator nodes. The architecture here is on the right side is EVM, it's parallel execution EVM. We're using, say, version 2 for that. So it's like one-to-one compiles whatever is Solidity anybody writes on ETH on any layer 2. That EVM runtime is connected to a Cosmos runtime, where we handle all of the chain logic itself, staking, posting the inference results back to those, making sure that consensus is reached. There's a model registry, all of that is handled on that side, and those two communicate between each other. Now, one thing from the challenges side that we faced was how to actually make inference verified. And there's a wide variety of design space. You can everything from CKML, OPML, oracles, actually running all of the neural nets inside EVM itself as well. Basically, it's doable, theoretically, but it's unfeasible because of the gas cost. And this is kind of version 5 of our architecture. And what we've concluded today is coming to an inference consensus on a model level. So here you can see all of the nodes here are running Llama 3. The nodes here are running Mixtral. The nodes here, you can bring your own model here. And imagine that every node here has to stake $1,000. And so you get, let's say you have 100 nodes here. So you get basically $100,000 of economical security guarantees if the developer here wants full consensus by all nodes that provides that inference. But the reality today is what we've seen from developers, mostly if they're building decentralized AI applications, they don't have high security needs at the moment. It will definitely come in the future point of time. But in the cases of, let's say, if you're building on-chain ChatGPT, you don't need a lot of security, but you want low overhead, you want to minimize the cost. So the security guarantees are basically configurable on this code level, and you can basically set the parameter of how many inferences, or sorry, how many nodes you want to execute the same inference and reach a consensus. And there's actually a next version of the same design here as well, where you can basically, something called proof of sampling can be used here as well to even further make this more efficient. And here on the left side, this is basically the model node. Again, and anybody who has a GPU can run an open source model and can start providing inference to the network. Alrighty, demo time. So I'll show you what's live today, which is we're currently on DevNet. On a DevNet phase, the execution, what I just showed you here, this is testnet. This is coming up hopefully in August. Now with DevNet, what we have is the execution is run in something called DML, so it's a hardware level enclave. And those are the like 50 plus teams have built, all of the projects that I showed have built on the DevNet with this DML. So let's say, and we basically, the benefit of running in a hardware level enclave is you can use closed source models, and you can also use tools which you need for agents. On the downside of an enclave is it's not like very secure. Like you're not able to secure like DeFi use cases with it. But again, in the cases of low value use cases, it's good enough. And we basically support majority of the kind of like latest models. Here is kind of like a front end for this. So sign a transaction on Galadriel chain. So this contract, we just got the response. See. So got the response, yada, yada, yada. Transaction hash of that. So this is the input. And that's also the output that was given by the Oracle. And all of those examples from a developer perspective, you can find on docs as well. So you have a lot of quick starts, tutorials, how you can build like simple LLM functionality, add to your Solidity code. You can even add like multi-model vision, use cases, agents, whatnots, etc., etc. And I'm going to also do a demo of this as well. We just deployed this on Friday. So let's see if demo gods are good and it works. So what I have here is like 2 nodes that are running Llama tree. So what I just opened up is one log of that model node. And what you're seeing at the moment here is like a ping from the node who pings the main nodes, the validators. And why you need to have a ping is you want to make sure the nodes who provide the inference are alive. If they aren't alive, then because they're staking, you get penalized. So just open up one contract, which is basically the same in terms of what I just showed on the screen, that kind of uses the same logic in terms of inference. And what I'm going to do is I'm going to deploy this contract. And now I'm going to call this contract out. And now from the client side, so what's the flow is gonna be is, so I just did this part. Now if I'm going to execute this transaction, it goes to these validator sets. Once that transaction reaches those validator sets, it will route. Basically, those nodes will listen to new requests and start the inference and post back the results. So the node just received this, who is the king of Web3, answered one word. It's running the inference, posted the result. And you also see something inference hash added here. So this is like a pre-commit. There would be like a free rider problem if all of the nodes could basically commit the results to the chain, and if there's a consensus necessary between all of the inference nodes, then game theory would be that most of the nodes wouldn't do any work. They would just listen to the chain itself, and whoever has posted results back there, they will post back the same result. But because of the pre-commit reveal, you can't lie. And so who is the king of Web3? Here we have it, Ethereum. Still today. Alrighty. How much time I have still left? So I'll show you one more thing. Nope. We also have, just as a showcase, like a fun showcase, it isn't fully ready, but you'll be the first to see it. And we will continue developing it during ETCC. And so basically what you can do here is, how many of you here are Lord of the Rings fans? Woo! Half of the crowd. Cool. So this is basically Middle Earth of AI agents. So you can go on a quest as a Frodo, and the gameplay is about, you have to gather different like swords and potions, whatnots from different characters, and then go slay Sauron Gensler, who is not the biggest friend of Web3, so he's the final boss. So this is my character. I can speak with other characters of this lore. And those characters here are like AI NPCs that are run on our chain. So that's like, gets you going, like, you know, what's actually possible now thanks to actually AI, bringing AI on chain. Send a transaction. So that's the secret how I can win against Soren. And again, like the transaction which I asked is on chain as well. So again, this game isn't fully ready, but you can find it on middleearth.ai. And I just recommend, you know, checking it out like in a few days from now. And at the end of ETCC, we're also going to select randomly and give out the prize between all of the winners who actually won against Soren. and it's going to be 500 USDC. It's a bit of fun and a bit of gains. And now I'm open to questions.
Hi. Can you hear me? Without okay. So thank you for the presentation. I mean, all these nodes they're running language models, right? Which are not deterministic. So how are you determining correctness? You have two nodes running the same model with the same prompts. They're going to spit out different things. So how do you know what is correct?
Yeah, that's a very good question, and it's actually kind of a misconception that models can't be made deterministic. By vanilla, they're deterministic, and there is a range how much of deterministic they are. For example, like llama models are quite deterministic compared to mixtural models, which are mixture of vector models, and they're much more like higher variability. But the way how you do that is we have a bit of like tricks up our sleeve, which we're going to publish also with the release of testnet. But in a short is basically you have the few steps you have to do. You have to quantize the models. You have to set specific flags on the hardware plus the kind of like PyTorch and etc. library level. And so models, and even like most extreme that we've seen is you basically write like custom CUDA kernels. You override some of those, and you can again like make models deterministic. So it was a kind of like a research question for us at one point as well, and today we have like empirical answer that it's the models can be made deterministic.
Thank you very much for the presentation. It was really, really good. You mentioned that data privacy is a major issue for AI and the blockchain. I don't know how you solve protecting the inputs with what you guys are doing. Is that something you've tackled already?
Yeah, I really like the question. I didn't show it to you at the moment, but it is part of our roadmap because, again, like we're very much like user and developer focused. Okay, what are actually users building today? What are they asking about, et cetera, et cetera. Data privacy is one thing, especially, and data privacy is going to be chunked into multiple categories. One is end user data privacy. But secondly, it's also about like if you're building an AI agent or an application, you usually add knowledge bases there. So you might not want to, let's say you add like PDFs or whatnots. It's like, nah, do I want to post it all on chain? Or probably not. So part of our roadmap, what we have is, let me see. Da-da-da. So it's quite still early, but NVIDIA is developing also hardware level enclaves. Currently, they only support kind of H100s, but to my knowledge, they should add hardware level enclaves to also end consumer GPUs from next year. So part of the roadmap is basically that in case you need data privacy, you basically, what you do is you take the enclave public key, and on the end user, so who creates the transaction, use the public key to encrypt their data, basically, so the user input. And that is sent in an encrypted manner to the enclave. Enclave can now decrypt that with their private key, compute to the inference, encrypt and send it back, and then can basically post back to the chain, which is fine, and the end user can read it and decrypt it.
Thank you so much. I really enjoy your presentation. My question might be a little dumb, but why do you want to deploy a model on chain? Like, why do you need to have every every chat, every prompt? Why does every prompt need to have a transaction hash, and what types of use cases would require this types of application? Because this is definitely a hard problem. It's really nice to see the demo, but I just don't quite understand. Is it necessary to put the model on chain?
Yeah, it's you're very much true that it is a very much hard problem. I guess the analogy I bring is, imagine if part of the execution flow of Ethereum today would be somewhere else. like hosted off-chain, like the core logic. So you wouldn't have the same security guarantees. So it basically comes down to the security guarantees that are necessary, and without being reliable on second or third parties. Like the Oracle design, it's basically anybody can spin up their own Oracle, but again, like what we've seen from the user side and also our own side, the applications that one develops on top of that, like for like maximum like $10,000. If you want to secure more than that, you need higher security guarantees. You want to have the full execution basically on chain.
But does it have to be a LLM? Like you can put a smaller model, like it's probably an easier problem. But why have to deploy like Llama like on chain?
Oh, you mean you ask? Let me see. So did you meant like adding the models here? Yes.
So it doesn't have to be a LLM, right? It can be
Yeah.
like
It can be
model.
any. Here in this, like once we roll out the testnet, you can add any kind of model, and if that model is actually useful, then and if developers start using your model, it will be a higher incentive for others to also start hosting your model as well. So also your model throughput scales. I didn't add it as a one kind of design constraint, but it's also a big constraint, like how to actually scale the throughput. So in this design, you can also scale the tokens per second throughput as well. And also the added benefit for you is if you get a really valuable model, you can start earning money out of from your model. And in the case of the NVIDIA hardware enclave, like even if you train a model, you can run it there, and like others can't leak it. So it's fully up to you, and you have attestations that the execution is correct while you earn the money. All right, thank you very much.